Hi, in this video, I'd like to work through some more examples of using the crisscross method. The first step is to find the oxidation number for each of these elements. I'm going to presume at this point that you can do that. So the potassium is +1 and oxygen is a -2. So if I crisscross these, this first one tells me, since that's a +1, it tells me I will need 1 oxygen. Since this is a -2, it tells me I will need 2 potassiums. So the final formula would be 2 potassiums and 1 oxygen to give me K2O. Here's our next one. Lithium is a +1 and fluorine is a -1. So when I crisscross them, it tells me I need 1 fluorine, and this tells me I'm going to need 1 lithium. Since I only need 1 of each, it's just LiF. Remember, you don't need to put the subscript if it's a 1. We leave them off. Our next one is a little bit trickier. Sulfur is a -2 and magnesium is a +2. Before I even go further, I'm noticing that the magnesium, which has a positive charge, should be listed first. So I'm going to go ahead and switch that order before I forget. I'm going to put the element with a positive charge first. So when I crisscross these, here's a 2, saying I would need 2 sulfurs, and here's a 2, saying I would need 2 magnesiums. So based on this, one would expect the formula Mg2S2. But we're not actually done. The last step is to reduce the subscripts if they all have a common factor. Now you notice both of these subscripts are 2. They both have a common factor of 2. So I need to reduce this down from 2 and 2 down to 1 and 1, which would give me the formula MgS. If one looks at the arrow model for this, here's the arrow model for MgS. One can see that even though, or because they have the same amount of charge, you really only need 1 of each. That's the trick with reducing it down. Basically, you need to find the least common multiple of electrons. That will make it work out. So you want to make sure you reduce them as necessary if they can. Here's the final one, Ca and Si. So calcium's a +2. Silicon is tricky because it can be a +4 or a -4. It's a halfway element. But we know that it will make an ionic bond, and we also know that the calcium's a +2. So to make an ionic bond, if this one has a positive charge, the silicon must have a negative charge. So we'll give it an oxidation number of -4. When we crisscross, this tells us we would need 2 silicons, and this tells us we would need 4 calciums. And that would give us the formula Ca4Si2. But once again, we need to check to see if these can be reduced by a common factor. And it turns out both subscripts have a common factor, 2. So we can reduce them down from 4 and 2 down to 2 and 1. So it will go to Ca2Si. Once again, if you look at an arrow model, you can see that this is exactly how it works out. So, just to sum things up then, when you use the crisscross method, make sure you list the positive element first, and make sure that if the subscripts you get after crisscrossing have a common factor, that you reduce them down.